video we are going to attempt multiple choice paper C, and this is from college board. So first question says that three ions of different elements are shown above. Which of the following element which of the following statement is correct? So first of all, let's find their number of subatomic particles. First, find the neutrons for chlorine. Neutrons we can find by subtracting atomic mass by atomic number. So neutrons are 20. Electrons are 17 is its atomic number. It has gained one electron, so 17 plus 1, that becomes 20. Protons are equal to the atomic number, so they are 17. For phosphorus, neutrons are 31 minus 15, that comes out to be 16. And if we are seeing the protons here, protons are atomic number which are 15. And if we are seeing the electrons, electrons are 15 as it has gained 3 electrons having negative charge, so plus 3, that becomes 18. If we see potassium, then its neutrons are 37 minus 19, and that comes out to be 18. And if we see its proton are 19, and electron is going to be 19 minus 1 because of the positive charge, so it is going to be 18. So first statement says all three ions have the same number of electrons. This is 20. Okay, so they are having, how many electrons are there? Oh, 17 plus 1 is 20, 18. So it has 18 electrons. So electrons are 18 for chloride ion, they are 18 for potassium, and for phosphorus they are 18, and for potassium they are also 18. So electrons are same for everyone, so option 1 is correct. None of the ions have the same number of neutrons. So neutrons here are 20, here are 16, and here we have 18. So neutrons are different for everyone, so it's right. They are saying chloride ion and potassium ions have same number of subatomic particles. Subatomic particles means neutron, proton or electron, so we have to add them. So chloride ions are this, like 20 plus 18 plus 17, which are protons, so that comes out to be 55. And for potassium ions we have 18 neutron, 19 proton and 18 electron, 36, that also comes out to be 55. So this option is also right, this is also right, this is also right, so A is going to be the right answer. For question number 2, they are saying how many molecules of propane does a 23 gram of sample of propane contains. So first you need to find the moles. Mole is equal to mass by molar mass. Mole is 23 and molar mass is going to be 44.084 for C3H8, and that comes out to be 0.5217. And we have a formula, that is number of particles, which is equal to mole times Avogadro's constant, which is 6.02 times 10 to the power 23. Number of particles could be atom, they could be molecule, and they could be an ion. So they are asking about molecule here. So mole is how much? 0.5217. Times it with 6.02 times 10 to the power 23, and the answer that comes out to be 3.14 times 10 to the power 23. So our answer is going to be D. Now moving further, consider the chemical compound H2S according to the law of definite proportion. Which of the following statement is true? So according to law of definite proportion, first this is hydrogen to sulfur. This is sulfur. We need to make this correction. This is also sulfur, and this is also sulfur as well. So according to law of definite proportion, what they are saying, there is a statement that I am going to write for you. So law of definite proportion says that ratio of mass of elements in a pure compound is always the same regardless of the source of the reaction condition to form a compound. So if we see option B, which says that the mass ratio of hydrogen to sulfur in H2S is always the same regardless the sample. So that is according to the statement of law of definite proportion. So answer is B. So for the next question, which element has the smallest atomic radius? First of all these elements are present in period 3. And we know one thing, as we move from left to right in the periodic table, then what happens? Atomic radius decreases. Atomic radius decrease. Why? Because of increase in nuclear charge. As the nuclear charge means the number of protons increase, they are going to have more pull towards the valence electron, which cause the size of atom to decrease. And also, as you move from left to right, shielding electrons remains constant, and if shielding electrons are constant, then that would result in the decrease in atomic radius. Now afterwards, what happens, like if you see chlorine is present in group 7, that is present in like group 7, and that is present in the most right part, most rightwards, that is present most rightwards. So size will decrease, and that's going to be D. It is going to have the smallest size. In the reaction, H2 plus Cl2 reacts to form 2HCl. How many moles of which chemicals will remain when 1.5 moles of chlorine reacts with 2 mole of hydrogen? So first of all, we are having 1:1 of hydrogen in chlorine, and as 1.5 moles of chlorine are reacting with 2 mole of hydrogen, so this is going to be a limiting reactant. That's going to be a limiting reactant. And if it is going to be a limiting reactant, that would controls the amount of product. So controls amount of product. So if we have like 1.5 moles of chlorine and 2 moles of HCl, according to equation, like 1:2 is there. So if it is going to be like if it is going to be 1.5 moles of chlorine is there, then it is going to form 3 mole of HCl first of all. So 3 mole of HCl is going to be the option D. One thing they are asking, like they are saying at the end 0.5 moles of hydrogen is remaining. So initially they were having 2 moles, but as chlorine is a limiting reactant, so excess H2 which has been remaining, you can find by 2 minus 1.5, and that comes out to be 0.5. So our answer is D. Moving further, which statement best describes the intramolecular bonding in carbonate ion? Intramolecular bonding means like the covalent bond which is formed in between the atoms. This is the covalent bond, and the covalent bond is described by electrostatic force of attraction that is present between nucleus and shared pair of electron. So our answer is going to be B. So for the next question, they are saying nitrous oxide is produced when nitrogen dioxide reacts with water to produce acid rain. What is the correct Lewis diagram for nitrous acid? Nitrous acid is HNO2. First, let's calculate its valence electron. Hydrogen is having 1. Nitrogen belongs from group 5 having 5 electrons. Oxygen is having 6 electrons, times it by 2, and that comes out to be total 18 electrons. So first let's count the 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it shows the correct diagram, and you can see the octets are also completed in this one. So our answer is going to be A. And let's see the other options as well. Like if we see this option, so if we see B option, then you are going to see that the octet of nitrogen is not completed. Octet of nitrogen is not completed. So this option is going to be wrong. And if we see the second option, then you are going to see octet of this oxygen is not completed. And if you come towards the next part, you are going to see that there are excess electrons which are bonded with oxygen. So this is also wrong. They are wrong as well. So next question is, which of the following statement explains why ionic compound tends to have high melting point? Basically because of, like for example, NaCl, which has present like cation, sodium, and anion chloride. And the force of attraction they are having is electrostatic force of attraction that is present between cation and an anion. So this force of attraction, which is electrostatic force of attraction between cation and anion, that becomes the reason for high melting point and boiling point. So if we see option D, what they are saying, strong electrostatic force between oppositely charged and in 3D lattice require significant energy to overcome. This is going to be the right answer. For the next question, they have given us mass to charge value of different isotopes of strontium. Okay. Now they are saying we have to find the percentage abundance of strontium 86 and percentage abundance of strontium 87. If we keep it as Y, then we need to find the value of this one. So if we keep it as Y, then add the percentage abundance of all of them and then subtract it from like 100. So what we can do it like 0.56 plus Y plus 82.58. okay, and that comes out to be how much? That comes out to be 83.14 plus Y. And if we want to find the remaining abundance for this one, we can do it by 100 minus 83.14 and 83.14 and minus Y. So it comes out to be 16.86 minus Y. Now we have a formula of relative atomic mass which is going to be, that is given to us 87.71, which is equal to mass multiplied by mass is 84 times it with its abundance 0.56 plus you are going to have 86 times with the Y plus 87 times with 16.86 minus Y plus 88 times with 82.58 and divide that one by 100. So after solving them, like you are going to have the final value which is 87.9 minus y, which is equal to 8771, and y comes out to be equal to 9.90. So its percentage abundance is 9.90, and if we want to find the percentage abundance of this one, so 16.86 minus y, which is 9.9, and that comes out to be 6.96. So our right answer is going to be B, 9.90 and 6.96%. The correct shape of ClF2 minus is, first of all we have to find its valence shell. So 7 plus 2 times 7 plus 1, and that comes out to be how much? That comes out to be 22. So Cl we are going to put here, fluorine we are going to put here, fluorine we are going to put here. So that corresponds to, like we can draw the Lewis structure, and we have two lone pairs on chlorine. How many electrons becomes? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20, but total are 22. That means the central atom is going to have the expanded octet. Chlorine, as it belongs from period 3, is going to have an expanded octet. So the remaining lone pair is going to come on chlorine, like at this point. And if we draw its structure, it becomes chlorine, like I'm putting F here, I'm putting F here, and lone pair I'm going to show here, and the other lone pair I'm going to show here, and the other lone pair is going to be there, and collectively it is going to have a negative charge. So you can see it is going to have the linear structure. So A and B both are linear, so we can choose B. Next question, the diagram above represents a particle in aqueous solution. Which of the following statement about the particle is correct? First of all, they are basically dissolved in water, and if dissolved in water, you can see this bigger one is basically water is having this structure: oxygen, hydrogen having lone pair there, partial negative charge on hydrogen, oxygen, partial positive charge on hydrogen, partial positive charge on hydrogen. So this one is representing basically oxygen there, and oxygen, as it is having partial negative charge, then definitely that must need to be a cation which is having a positive charge. So they are asking which is going to be the particle, so you can say the particle is a cation. Next question, question number 12. Question number 12, what we are going to do with this question number 12, they are asking which of the following solution contains the greatest number of moles of chloride ion. So first we need to find the moles, and then we have to multiply with the number of ions. So moles for it is going to be concentration, which is 0.1, times with the volume, which is 25 divided by 1000. We have to convert it to liters, so that comes out to be 0.025. And as there are two chloride ions, so I'm going to multiply it with 2, so the answer comes out to be 0.005. Then for the next part, again concentration 0.15, times it with 0.01, and that comes out to be 0.0015. For the next question, again concentration times with the volume, that is 0.02, and times with the number of ions, that are two chloride ions, so I am multiplying it with 2, so that comes out to be 0.008. For the next question, 0.1, which is concentration, times with the volume, which is 0.01, and there are only one chloride ion, so I am not going to multiply it, so it is 0.001, and the answer comes out to be C. Then for the next question, which of the following could be the identity of a solid that exhibit the following properties? Like it melts at 996, so that means it is going to have high melting point and boiling point. And the next one, it does not conduct electricity as solid, that means it does not have free moving ions. Free moving ions. And for the next part, it conducts electricity when dissolved in water, because in that condition it is going to have free moving ions. So these are all characteristics for ionic compound. So we need to choose ionic compound from the option, and our answer is going to be A, magnesium bromide, in which magnesium is a metal and bromine is a non-metal. So the next question, they have given us Boltzmann distribution graph. So now they are saying if the temperature is increased, what will happen to the position of point X? So if the temperature is increased, then what happens? Like we are going to have a new graph like this. And now we are going to have you can see the position of X that becomes lower, and it also comes on right hand side. So now we can say like the fewer molecules possess the most possible energy value, so X will shift to the right. Answer is going to be A. What is the significance of an intermediate species in a proposed reaction mechanism? So, what is intermediate species here? That the one which is formed during the elementary step, during the one elementary step, and also consumed in next elementary step. So it will not appear in the equation. So it will not appear in the equation. So you can write the like select the option B. It is produced in one elementary step, but it is consumed in a subsequent step. So it will not come in the final equation. For the next question, question number 16, they are saying like as you can see, the molecules, their boiling point is increasing down the group. Boiling point increases, and they are having London dispersion forces. They are having London dispersion force, and London dispersion force, they are dependent on number of electrons. So greater the number of electrons, stronger will be the London dispersion force. So our answer is going to be B. So for the next question, which of the following is the conjugate base of carbonic acid? So carbonic acid is H2CO3 and is a weak acid, and when it donates a proton, it forms HCO3 minus plus H positive. This is acid, and when it donates a proton, that becomes its conjugate base. So if this is conjugate base, then you can see HCO3 minus is going to be the conjugate base. For the next question, for the reaction C2H5Br plus OH minus, it forms C2H5OH plus Br minus. So if you see here, like when you are increasing C2H5Br by 2 times, OH minus need to be constant. It fulfills the condition that is constant, and it is also increasing 2 times. So rate of reaction with respect to C2H5Br is going to be first order, because when concentration doubles, rate also doubles. And now for OH minus, if we see experiment 2 and experiment 3, they are getting double. and here that needs to be constant, and it is also getting doubled. So if concentration of OH minus is doubled, rate is also doubled. It is also going to be first order, and for first order the rate equation is going to be A. Why? Because at C2H5Br it is nothing written there, that means it is 1, and OH minus nothing is written there, that means it is 1 as well. Now for the next question, identify the type of energy transition shown in the diagram. And the diagram shows covalent bond stretching. This is a covalent bond, and this covalent bond is showing the stretching of molecules. So stretching of molecules in covalent bonds, they are basically related with infrared radiation. So infrared radiation is basically associated with, that is associated with molecular vibration, such as bond stretching. So our answer is going to be infrared radiation, that is C. Next question. The first stage in the industrial production of nitric acid from ammonia can be represented by the following reaction. Enthalpies of combustion of the substances involved in the reactions are given below. Use the information above. What is the value of standard enthalpy change for the reaction? So enthalpy of reaction, we have formula, that is summation of enthalpy of combustion of product minus summation of enthalpy of combustion of reactant. So if we see products there, product is 4NO, 4 times NO is 92.2. I'm going to put a bracket here, plus 6 times water molecules, that is minus 239.6, minus reactant are 4 times NH3, 4 into minus 51.3, and the answer that comes out to be is minus 863.6 kilojoules per mole. So our answer is going to be C. For the next question, they have given us two acids along with their Ka value. They are saying the correct solution to form a buffer with a pH of 4.77 is. So first we have to find their pKa value. pKa value is negative log of hydrogen ion concentration. Negative log of Ka. So negative log of Ka value is 1.7 times 10 to the power minus 5, and that comes out to be 4.77. Then also finding the pKa here, negative log of Ka is 1.8 times 10 to the power minus 4, and it comes out to be 3.74. So pH is 4.77, so that matches the pKa value of acetic acid. So first of all, that is going to be acetic acid, either this one. Then one thing that is like buffer solution. If we see buffer solution are made when half of weak acid is neutralized. So as the concentration, you can see that as concentration of NaOH will neutralize half of acetic acid, and the buffer solution will made and the buffer solution is made. So concentration needs to be the same. So if you see 0.1 molar acetic acid which is combining with the same concentration of sodium hydroxide, and at the half volume, you can say what happens. There is a buffer solution that has been formed when half of as a weak acid is neutralized. So our answer is going to be A. For the next question, they are saying a 0.10 molar decimeter cube solution of propanoic acid is titrated with 0.1 molar dm cube potassium hydroxide. So what is half equivalence point? The half equivalence point is the stage of the titration at which exactly half amount of acid has been neutralized, and at that time what is going to happen, like we have two acid which is propanoic acid. This is propanoic acid, CH3 CH2 COOH. That concentration becomes equal to its salt, that is CH3 CH2 COO minus. So what happens at half equivalence point? pKa is also equal to pH at half equivalence point. So our answer is going to be D. Next question, they are saying lead nitrate reacts with aqueous potassium iodide to produce solid precipitate of lead iodide and aqueous KNO3. So we have to write the net ionic equation. So what happens when lead nitrate, which is in aqueous form, and they are reacting with potassium iodide which is also in aqueous form, and they are going to form PbI2 which is going to be in solid form and is going to form 2KNO3 in aqueous form. So what happens when I'm going to split them up? It is going to form Pb plus 2 aqueous form plus 2NO3 minus in aqueous form plus 2K positive in aqueous form plus 2I minus in aqueous form, and they are going to form lead iodide in solid form plus 2K positive in aqueous form plus 2NO3 in aqueous form. So what happens from both sides? Potassium they are acting as a spectator ion, so they will be cancelled out, nitrate, and the remaining equation would become lead iodide in aqueous form plus 2 iodide in aqueous form, and they are going to form lead iodide as the precipitate. So our answer is going to be D. For the next question, they are saying the blood red complex ion thiocyanate is formed when yellow iron 3 ions, this is having yellow color, with colorless thiocyanate ions in the following reaction, and it is having blood red color. So they are saying which of the following changes should shift the equilibrium to make the solution lighter. Lighter is yellow color, that means it is going to shift towards left hand side. As they are saying forward reaction is endothermic and the backward of course is going to be exothermic. So what happens if we are like we have to shift it towards the left hand side? So definitely, as the backward direction is exothermic, we need to decrease the temperature of the solution. So our answer is going to be B, because if the temperature is decreased, the according to Le-Chatelier principle, the equilibrium will move towards that direction in order to increase the temperature So that's why it needs to move towards exothermic direction. So for the next question, they are saying when 300 milliliter of 1.5 molar KOH is added to HBr, the pH of the resulting mixture is closest to. So first let's find out the moles of KOH, that is concentration times volume. Concentration is 1.5 multiplied by the volume, which is 0.3. We have to convert it into liters. So the answer comes out to be 0.450. Then we have to find the moles of HBr. So that comes out to be concentration 0.8, volume is 0.4, and that comes out to be 0.320. Now, as we know that KOH plus HBr, when they react, they are reacting in 1:1 because they are forming KBr plus water. So they have 1:1 between them. Then you can see one thing, like if they both are reacting, so KOH is in excess. KOH is in excess, and if we want to find out like moles of KOH which is going to be remaining, you are going to do 0.450 minus 0.320, the excess KOH moles, that comes out to be 0.130 moles. Now we are going to find the concentration of OH ions, because that is basically coming from KOH. So concentration of OH ions are mole divided by volume. Mole is 0.130. Volume is going to be like when we are mixing them, so their volume becomes 700 milliliter. 700 milliliter divided by 1000, that comes out to be 0.7, and this comes out to be 0.186 molar. This is basically the concentration of OH ions, and that is 0.186 molar. Now we have a formula, Kw is equal to hydrogen ion times OH ions. So Kw is 1 times 10 to the power minus 14. Hydrogen ion we need to find out. Hydroxide ion is 0.186, and hydrogen ion comes out to be how much? That is 1 times 10 to the power minus 14 divided by 0.186, and that comes out to be 5.38 times 10 to the power minus 14. So this is hydrogen ion concentration, and if we want to find its pH, which is equal to negative log of hydrogen ion concentration and negative log of 5.38 times 10 to the power minus 14, that comes out to be 13.3. So our answer is D. So for the next question, the reaction above occurs in a 1.0 liter sealed container at 500 Kelvin, and what happens, initially the concentration was 0.05 of C2H6, and the following data shows the concentration of hydrogen over time. So when you see the concentration of hydrogen over time, you are going to see like from this time to this time, the concentration of hydrogen that becomes constant. Concentration of hydrogen becomes constant. Then you can see that if the concentration becomes constant here, then that means equilibrium was established there. And when equilibrium was established there, you can say that equilibrium was established between 200 to 300 seconds because the concentration of hydrogen stops changing. So our answer is going to be A. So condensation appears on a bathroom mirror. Which of the following is true? For condensation, you are going from gas to liquid state, and you know one thing, that gas is at high energy, and the liquid is going to be at low energy. So as you are moving from high energy to low energy, what happens? Energy release. And if energy release there, then this is going to be exothermic. And you know that gas is basically more disordered, its particles are more disordered, and as you move towards liquid state, it is going to be less disordered. So if it is going to be less disordered, you know one thing, from more disordered to less disordered, if you are moving, then entropy decrease. So first of all, like it is, and the exothermic, when it is exothermic, then it is going to have negative enthalpy. So first of all, it is going to have negative enthalpy, and it is also going to be entropy decrease, means negative entropy. So what happens? Our answer is going to be D. So next question is saying addition of the following salt will affect the solubility of zinc carbonate. Zinc carbonate is very slow soluble in water. It forms zinc ions plus carbonate ions. So if we see, like first of all, sulfuric acid. So sulfuric acid, what happens? It forms two hydrogen ions plus sulfate ions. And what happens? These hydrogen ions, they would react with carbonate ion and would form H2O plus carbon dioxide. So basically they consume carbonate ions, and what is going to happen? The carbonate ion will decrease, and it would have the more solubility as the equilibrium would move towards the right hand direction. For any HCO3, we know one thing, that it is going to have sodium ion plus hydrogen ion plus carbonate ion. Okay, like sodium ion and HCO3, you can say, or hydrogen ion as well, and with carbonate ions, let's say. So it would definitely affect the solubility, as it has hydrogen ion which can again react with carbonate ion. So with zinc nitrate, what happens? That is zinc nitrate, which is going to be 2. Yeah, and when it is going to form zinc plus 2 nitrate ions, so what happens? It increase the quantity of zinc nitrate here, and the equilibrium will move towards left hand side. Like for sodium sulfate, you can see one thing, it is going to have 2 sodium ions plus sulfate ions, which has no common ion in between them, so it is going to have no effect on the solubility of zinc carbonate. So our answer is going to be D. Then for question number 29, a sample of chlorine gas with a mass of 5.35 grams, so moles of Cl2 is equal to mass 5.35 divided by molar mass, which is 70.9, is going to be equal to 0.075 mole. And temperature, if we want to find temperature is equal to PV over NR. PV is how much? P is pressure, which is 1 atm. Volume is 1.25 liter. Moles are 0.075 mole, and the value of R is 0.08206. The answer that comes out to be is 203 Kelvin. So for the next question, they are saying the reaction above has a standard entropy of 161 joules per mole per Kelvin. The reaction has a standard enthalpy change of 178. Calculate the free energy change. That means you have to calculate Gibbs free energy, which is equal to delta H minus T delta S. Delta H is 178 minus temperature is 25 degrees Celsius, but we have to convert it into Kelvin. That comes out to be 298 Kelvin, because we have to add 273 into it. so 298. And for entropy, it is given in joules per mole per Kelvin. We have to divide it by 1000 to convert it into kilojoules per mole per Kelvin. So always we have to convert it into kilojoules per mole per Kelvin when we want to find Gibbs free energy. So it is going to be 0.161, and the final answer that comes out to be is 130 kilojoules per mole, and this is going to be Gibbs free energy. So our answer is going to be C. 1 mole of a compound reacts with 9.5 mole of oxygen for complete combustion. What is the formula of the compound? Plus O2, and that is going to form CO2, plus during complete combustion CO2 plus water is going to form, and here plus O2, and it is going to form carbon dioxide plus water, and again it is going to be O2, and it is going to form carbon dioxide plus water. Again O2, it is going to be carbon dioxide plus water. So now we have to balance it. So there is a rule. First you are going to balance carbon dioxide, then water, and then oxygen. So first, like, balance carbon dioxide. How many carbons are there? 6. So we need to put 6 here. And how many hydrogen are there? 14. So I have to put 7 here. So how many oxygen becomes? 6 2s are 12. 12 plus 7 is 19. So 19 are there. So in order to balance it, I have to put 9.5 O2 here. Okay. So like, it is balanced, and we also need 9.5 moles of oxygen. So our answer is A. Let's do it for the second part as well. Like, again we have to balance first carbon dioxide, so I have to put 6 here. How many hydrogen are there? Total 14, so I have to put 7 here. 6 2s are 12 for oxygen, and again there are like how many there? 6 2s are 12. Yes, now we have one oxygen here as well. So we have 19 on the right hand side. So 1, subtracting 1 which is on the left hand side, and then we have to put 9 here as well. So for carbon dioxide I need to put like 7 here, and for hydrogen I am going to put 8 here. So oxygen becomes 7 2s are 14. 14 plus 8 is 22. So that is going to be 11. So carbon dioxide 7, hydrogen we have 8, and total becomes 7 2s are 14 plus 8, that is 22. So I'm going to put 11 here. No, 7 14 plus 8 is 22. So one oxygen is already there, so we have to subtract that one. So that comes out to be 10.5, because we have to balance only 21 oxygen. Next question, consider the following reaction mechanism. A plus B is forming C, C plus D is forming E. If the experiment rate law is found to be rate is equal to K into concentration of A, B, D, what can be concluded from the relationship between K and rate constant of the individual step? So first of all, if we consider the fast reaction, then here K forward times the concentration of the reactant. For forward reaction, we are going to write K forward, the concentration of reactants, like this. And when we are going to write it for the backward reaction, we are going to write for the K backward, and for backward we are going to write the product, which is going to be C. And when we are going to keep both of them equal, because rate of forward reaction is equal to rate of backward reaction at equilibrium. So K forward, concentration of A, times for B is equal to rate of backward, which is K backward, and concentration of C. And when I'm taking, let's say, when I'm taking K forward over K reverse, like if K backward becomes here, K forward over K backward, then this one would become like we are going to have concentration of C over the concentration of A and the concentration of B. And this one K forward over K backward is equal to K equilibrium. Okay, and if I'm going to put concentration of A and B on this side, and we are going to keep it equal to the concentration of C. Now let's move towards the slow reaction. For slow reaction, we know rate is equal to, let's introduce another constant which is K2 to the product of reactants, because this is the rate equation and we only need to write the reactants there. Now putting the value of this C here, it becomes K2 K equilibrium times C times D. No, we also need to write, sorry, for C we are going to write the concentration of A, the concentration of B and the concentration of D there. Now we know here one thing, like instead of them, if we take it equal to K is equal to K2 K equilibrium, then this becomes rate is equal to K concentration of A, concentration of B, concentration of D, which is the required one. Now keeping K is equal to K2 K equilibrium, which is equal to K forward over K backward, K forward over K backward, and this equation is basically, this option is equation B, which is telling us K is equal to K1 K2 over K minus 1, where K1 and K minus 1 are the forward and the reverse rate constant of step 1. So you know, like K2 like K forward, this is going to be K2, this one, and this K backward, they are basically the constant of the forward and reverse constant for step 1, and K2 is the rate constant for step 2. So K2 here is going to be the rate constant for step 2. This is step 2. So this goes along with this option. So let's move towards the next question. Now they are saying an experiment is set up to determine the values of Faraday's constant for electrolyzing dilute sulfuric acid, which experimental measurement is not required to calculate a value of the Faraday constant. So when you want to calculate charge is equal to current times current multiplied by time. So we would be needing current, we would be needing time as well, and like for example, if we have, let's say, sulfuric acid, which is 2H positive plus 2 electrons, and they are producing hydrogen gas, and in order to find the mole of electron, we need to do, like, there are 2 moles of electron, 2 times the mole of hydrogen collected. So we would be needing the volume of gas as well to find out the mole of electrons there. So volume is necessary for us to determine the mole of electrons, but we would not be needing temperature here. So answer is going to be B. So for the next question, they are saying we have hydrogen, binding energy that has been given to us, and helium. Now they are saying why the binding energy of helium is greater than that of hydrogen. The reason is very simple, because helium contains 2 protons 2 protons. So it has higher nuclear charge as compared to hydrogen, as compared to hydrogen. So it is going to have higher binding energy, which is basically for helium. So let's see the options there. Helium has a greater nuclear charge than hydrogen and an additional electron in the same energy level. Like helium is having the electron in 1s2 and hydrogen is only 1s1. So helium is having one more electron in the same energy shell. Moving towards the next question, which of the following best explain why the reaction represented in the table are exothermic? So for exothermic reaction, energy release during bond forming, because energy is released during bond forming is greater than energy absorbed during bond breaking. So bond breaking occurs on the reactant side, bond breaking occurs here, and bond forming occurs on right side. So just remember one thing, energy released during bond forming is greater than energy absorbed during bond breaking, and this has been explained to us by option B, which is saying energy released in forming the bond in the product is more than the energy required to break the bonds in the reactant. So option B is going to be the right one. Then for the next question, which is question number 36, what is the value of the equilibrium constant when the equilibrium concentration are O2 is equal to 0.8 and O3 is 0.8. So when first we are going to write the Kc is product over reactant, product is O3 and raised to power square, and at bottom we are going to have O2 raised to power cube. O3 is how much? 0.8 whole square, and O2 is going to be 0.8 whole cube, and the answer comes out to be 1.25, and this is going to be A. For the next part, they are saying we have compounds pentane and heptane having the boiling point difference between them. You can see a lot of boiling point difference, and whenever we have the greater boiling point difference between them and the liquids are miscible with each other, miscible means they are dissolved into each other, then which of the following technique would be the best for separating the component of the mixture and why? That is going to be distillation. Why distillation? Because whenever we are going to have the difference in boiling point and the liquids are miscible into each other, means completely mixed into each other, then like they are going to be separated in the process of distillation only. So for the next question, we have been given a graph and they are saying equivalence point is 8.72 and pH of half equivalence point is 4.90. So at half equivalence point we know pH is equal to pKa. So the value of pKa here is going to be 4.90. So for pKa we have a formula, negative log of hydrogen or negative log of Ka. So when pK has been given to us, which is 4.90, which is equal to negative log of Ka, and if we are going to find the value of Ka, that is going to be 10 to the power minus 4.90, which comes out to be 1.26 times 10 to the power minus 5, which is Ka. So our answer is C. For the next question, what is the correct formula to work out the formal charge on an atom? This is quite evident. That is equal to the number of valence electron minus 1 by 2 number of bonding electrons minus number of non-bonding electrons. So our answer is A. Next part, for 40, 100 milliliter of potassium carbonate of sodium carbonate of an unknown concentration is reacted with excess calcium chloride solution. The resulting sodium carbonate precipitate is filtered and dried. The following data is recorded. So first of all, you need to find the mass of calcium carbonate. You know, this is the mass of filter paper plus calcium carbonate precipitate, so I am going to find it by subtracting them. 1.94 minus 0.77, so that comes out to be 1.17 grams. And then mole of calcium carbonate is going to be mass, which is 1.17 divided by molar mass, which is going to be 100.09, and that comes out to be 0.01169 mole. And you know one thing, according to the ratio, there is 1:1 with sodium carbonate. So the mole of calcium carbonate would be equal to the mole of sodium carbonate. That comes out to be 0.01169 as well. And then you have to find the molarity of sodium carbonate, and that is equal to moles. 0.01169 divided by, we are going to have volume, which is 100 milliliter. We have to convert it into liter, so divided by 1000, that becomes 0.1 liter. So this is 0.1 liter, and our final answer that comes out to be is 0.117. So which of the following best describes the difference between crystalline and amorphous solid? So crystalline solid, first of all, let's write some characteristics of that. So for crystalline solids, first of all, they have highly ordered, regularly repeating arrangement of particles. So because of they have ordered structure, they are going to have high melting point, while amorphous solids have a disordered atomic arrangement which does not have long range order found in crystalline solids. So that's why they are going to have low melting point and boiling point. So the option B suggests us this thing, that crystalline solids have an orderly arrangement, orderly repeating atomic structure, while amorphous solid have a disordered non-repeating structure. So for the next question, this reaction, first of all, we need to see this reaction is what? This is reactant and they are product. So what is happening in the reaction? If you see that as the reaction proceed, the heat is absorbed. So when the heat is absorbed, the reaction is going to be endothermic. First of all, the reaction is endothermic. And now if you see the forward direction, what happens in the forward direction, we are going to have like activation energy. So this is the activation energy for forward direction. Activation energy for forward, activation energy is the energy required to start a reaction. And for the backward reaction, this one from this point to this is going to be the activation energy for backward. So for forward reaction, if you see, the activation energy for forward reaction is greater and the reaction is endothermic. So option D is stating us this thing, that delta H is endothermic and the forward activation energy is greater than the reverse activation energy. For the next question, if you see the ionization energies here, then you can see like after the second ionization energy, then you can see a sharp increase. You can see a sharp increase Because of the sharp increase, you can see one thing, like this atom which is X needs to have two electron in its outermost shell. So it has two electron in its outermost shell, but it is going to lose these two electrons, so it become a cation which is having two electrons. And why is there a sharp increase? Because that means like the third electron is withdrawing from the inner shell, is withdrawing from inner shell, and that is why there is going to be a sharp increase in the ionization energy between second and third ionization energy. For the general reaction, V plus W plus X forms Y plus Z. The rate equation is this. So what will happen to the rate of reaction when the concentration of all three reactant is doubled? So let's say if the concentration is doubled, then it would become 2 times, as they are first order, and 2 times 1, that is a first order, 2 times 1, that is a first order. So rate, that would become K times 8. So that means it increased by a factor of 8. For the next question, which of the following should be considered when determining the Coulombic force between ions? So two things are important for them: charge of the ions and the distance between the ions. So charge of ions, charge of ions is directly proportional to the Coulombic force, and distance of ions, like distance of ions, is inversely proportional to the distance between ions is inversely proportional to the force. So our answer is 1 and 3, and we will go with the option D. Which mixture will not act as a buffer? So for the buffer you need a weak acid and a weak base. A weak acid or a strong base? So either a weak acid and strong base, or either a weak base and strong acid. So you can take either of them. But if you see option C, it is going to be strong acid and a strong base, so this could never be a buffer. So for this question, a current of 1.5 ampere is passed through molten AlCl3 for 2 hours. So first, what volume of chlorine gas is measured at the anode? So first you need to find the charge. Charge is equal to current times time. Current is 1.5 ampere. For time, you need to multiply 2 times 60 times 60, and that is 2 times 60 times 60. That comes out to be 10,800 coulomb. When you need to find the mole of electron, what you need to do, you are going to divide 10,800 by Faraday's constant, which is 96,485 coulomb per mole. This mole will come up and it would comes out to be 0.1119 mole. So we know as 2Cl minus is forming Cl2 plus 2 electron at the anode, and when we want to find the moles of chlorine, we have to divide this 0.1119 by 2, because it is releasing 2 mole of electrons. So this one would become 0.05597. And now there is a formula: number of mole, this is for gas, volume of gas divided by molar gas volume, which is 22.4 liter at STP, standard temperature and pressure. So volume of gas is equal to number of moles are 0.05597 times 22.4, and that comes out to be 1.25 liter. So answer is going to be C. So for the next question, we have an equation: x2 plus y2 is forming 2xy. So when we write the Kc of this equilibrium, that is going to be xy, that would comes at top square over x2 times y2. So then it is going to be, for Kc the values are going to be, now let's see how many xy are there. Xy are 1, 2, 3, 4. So there are 4 xy. And how many x2 are there? X are 1, 2, 3, 4. And how many y2 are there? They are 1, 2. So it is going to be 4 whole square over x2 is 4 and y is 2. So that is 4 square, you are going to cancel it, 2, 2. So Kc comes out to be 2. Answer is C. Under which condition is the solution most likely to be formed? So when the solvent solute attraction is going to be greater than solute solvent interaction. This is the first condition for it, and it allows solute particle to be surrounded by solvent particles. So the right answer is going to be B, when solvent solute interaction are stronger than solvent solvent interactions. So for the next question, a scientist is examining a liquid mixture that contains water, ethanol and dissolved chloride. The mixture appears uniform to the eye and shows identical properties when analyzed in various parts. So first of all, if it appears uniform, that means it is going to be a homogeneous mixture. Homogeneous mixture is going to be that mixture which is uniformly mixed. So the answer is going to be A. The sample is a homogeneous mixture because the components are mixed at the molecular level and are uniformly distributed. So for the next question, they have given a certain half reaction and their E0 values. A standard galvanic cell is made using SN nitrate and copper nitrate half cell. Which of the following modification to the cell will cause the greatest increase in E0 of cell? First of all, E0 of cell we can find for both of them. They have the values which are this, and they have the value which is going to be copper this. So that is going to be, this is cathode more positive and this is going to be anode. Cathode is 0.34 minus 0.14, and that comes out to be 0.48 volts. Now they are saying replacing the copper nitrate half cell with the Hg and Hg nitrate half cell. So if there is copper nitrate which is 0.34, and if we are replacing with Hg, then it becomes how much? 0.79 will come here, minus 0.14, and the answer that comes out to be is 0.93 volt. And if I'm subtracting it from this value, then it comes out to be 0.93 minus 0.48. So it is going to have the increase of 0.45 volt. So this is the increase. Let's see the other options as well. When we are replacing this copper nitrate Copper nitrate is, this is copper and this is Sn. If I'm replacing copper with manganese, that is minus 1.18, then it comes out to be minus 1.18 minus 0.14, and the answer comes out to be minus 1.04. So if you compare like with this one, so it does not increase because the value is negative. And now replacing the Sn nitrate with Hg nitrate, so 0.34, replacing this Sn with the Hg, which is going to have the value of plus 0.79, so minus 0.79, so the answer is also in negative, so it does not show increase, does not increase. So up till now we have only A option which has shown an increase of 0.45. Now let's move towards when we are replacing Sn nitrate with manganese. So that is minus like 0.34 minus which is 1.18, and it comes out to be how much? It comes out to be 1.52 volts, and when you are subtracting 1.52 with the original value which is 0.48, you are going to have the value 1.04 volts, which is going to show us the maximum increase. So D option is going to be the right one. So the graph below shows the potential energy as a function of internuclear distance between two unknown diatomic molecules A and B. So when you see both of the molecules, like when you see nitrogen, it is having triple bond, so it is having the high bond energy. That means a lot of energy is required to break the bond first of all, and it is going to have a short bond length as well because of triple bond. When we see iodine minus, it is going to have low bond energy. It is going to have low bond energy, and what it is going to be, and long bond length, and has long bond length. So I'm going to choose option A because this A is basically showing the nitrogen which is having the highest bond energy. Nitrogen having the triple bond is inert as well, highest bond energy it is having. And B is going to be iodine because it is going to have greater internuclear distance because it is having the greater size. It is having the greatest size. That's why. So option A is going to be the best one. 53. What observation best shows a chemical change occurs when a colorless liquid and the blue liquids are combined? So when a colorless liquid and blue liquid are combined, then you can see for a chemical change, the first thing is going to be that cloudiness appears. That shows a new product is formed. New product is formed and the chemical reaction has taken place. New product is formed, which shows that a chemical reaction take place. Chemical reaction take place. And also if there is a temperature increase, that means temperature increase indicates that the reaction is going to be exothermic. So these is the best option is going to be A because it shows that like the cloudiness appears, that means a new precipitate forms, a new product has been formed, and its temperature increase, that means it's an exothermic reaction where the temperature has increased as well. Then consider the following two equilibrium reaction with equilibrium constant Kc1 and the reaction 2 with equilibrium constant Kc2. Now they are saying what is going to be the relationship between them. Like if you see this equation, you are going to see that the reaction is reversed, and also we are dividing it by 2 as well. Like for the second one, the reaction is reversed and also dividing it by 2 as well. So in order to find out the value for Kc2, first of all, for the reverse, like the Kc1 needs to be written in the denominator because the equation is reversed, and when you are dividing it by 2, then you need to put it in the under root as well. So option C is going to be the right one. For question number 55, the diagram below shows Boltzmann energy distribution curves and activation energy lines. So first of all, if you see this P point on the equation, that is showing that you are using a catalyst. You are using a catalyst. Why? Because the activation energy is decreased. Activation energy decrease. So P is the one in which activation energy with catalyst. We have two options. Now let's see higher temperature. If you are seeing higher temperature, then that would be P, because when you are having higher temperature, the point will come at lower position and to the right as well. So this is at lower position, and the graph also move towards right direction. So this is going to be Y. So option B is going to be correct. 56. Which of the following is the acid dissociation constant for ethanoic acid? So ethanoic acid is CH3COOH, and they are forming CH3COO minus plus H positive, and Ka is the dissociation constant, and it comes out to be CH3COO minus times H positive, which is products, over reactant, which is CH3COOH. So our answer is going to be B. For 57, the number of ions present in 0.02 moles of ammonium phosphate is, like we are given with the number of moles. So what we need to do, we know there's a formula, like we need to find the number of ions which is equal to mole times Avogadro's constant. So that's going to be, mole is how much? 0.02 moles. And how many ions are forming there? This is ammonium phosphate, and they are forming 3 moles of ammonium ions plus phosphate ions, PO4 minus 3. So we have, like the total ions are 4, so we have to multiply with 4 times 0.02 times 6.02 times 10 to the power 23. So our answer is going to be 4.8 times 10 to the power 22. So our answer is going to be C. Now, the equation for electron affinity of carbon and nitrogen are shown above. Why is the electron affinity of carbon more favorable, like more negative than the electron affinity for nitrogen? Because what happens definitely, like why it's going to be positive, like we know, like for example, this is first electron affinity. When an electron has been added to it, then what happens, as a force of attraction is basically developing between an atom and the electron, so it is going to be energy is released because a force of attraction is developing. So first electron affinity is always going to be exothermic. After it acquires a negative charge as well, because when an atom gains an electron, it acquires a negative charge. So first electron affinity is exothermic because a force of attraction has been developing when an electron has been added to an atom. But what happens, as it is an ion, and when an other electron is adding into it, then it is going to have like a -2 charge, and this second electron affinity is going to be endothermic. Why endothermic? Because as you are adding second electron, there will be repulsion, there will be force of repulsion. Then in order to overcome the force of repulsion, you need to provide it energy. So you can say the electron added to carbon experience less repulsion than the electron added to nitrogen. So when you are adding electron to it, so it is going to face repulsion. That's why you can say it is going to have more repulsion when an electron has been added to nitrogen, and when an electron has been added to carbon, it is going to have less repulsion. So we can say one thing, the option A justifies that thing, and so it is going to be our right answer. So question number 59, which of the following phase change would result in the greatest energy in the potential energy of the system? So when you see sublimation, in sublimation you are going from solid, then to liquid, and then to gas state as well. So you are basically going towards liquid and then to gas. So this is the place where you are going to have greatest increase in potential energy of the system, because you are moving from solid to liquid to gas, and it is going to have maximum energy, and this is going to have the minimum energy. Which of the following elements is most likely to form an interstitial alloy with iron? So, interstitial alloy is what? When when smaller atom fits between larger atom. So we have to find out the smallest atom, which is going to be boron. Boron is B511, having only 5 electrons and 2 shells. So it is going to be the smallest atom. So it is the one that fits best in the iron. So that's going to be the example of interstitial alloy.